All right, welcome to another edition of the Focus Follow-Up Workshops. Today we are joined by Jeremy Simon and Andrew Kaiser, both working together on a number of projects, but specifically there's a development project that they're going to talk a little bit about in detail and the process involved with that. We do these events the fourth Friday of every month. And I'll pass it to Jeremy. Take it away.
Thanks, Ben. So I'm just going to sort of set some context here, and then the bulk of the discussion I'll let Andrew take the lead on. The way that this came about was a design effort that came together. Gosh, I'm trying to think of when we started this. It's been over 6 months, I think, at this point. I don't remember exactly how long, but we've been meeting, a group of volunteers have been meeting as what we're calling the collaborative design team. And we're meeting every week, and our goal has been to basically look at all of the existing designs that have come along, with the focus on hands for right now. We're just trying to come up with a new hand design, looking at all the designs that we have so far and kind of taking the best features of all of those, as well as kind of any lessons learned or things that we want to improve or things that we want to make easier for people, and trying to pull all that together into a new and improved design. And one of the other goals specifically, in addition to having some of the best of class features, is we wanted this design to be completely parametric, meaning that you can scale it all the way up or down as needed, but certain aspects of the design don't scale with everything else. So you can keep the spaces between moving parts the same. You can keep the sizes of screw holes the same. You can keep the sizes of the cable channels the same, while the overall size is scaled up or down. That's a very powerful capability that we have never managed to pull off so far. And I'm very pleased to announce that we have succeeded in that now, thanks mostly to Alexander, who's our lead designer on this, and he's done some phenomenal work in Fusion. And while I'm talking about this, I'm just going to show you, I'll share my screen just so you can see what we're talking about here. This is a work in progress. I need to stress that, but this is the hand design, and this is just obviously the hand portion of it that you're seeing here. But as you can see, it's a very kind of attractive aesthetic. We've built this to be based on real human anatomy, borrowing a lot from the shape of the kinetic hand, but also leveraging direct sort of skeletal anatomy models and things like that. And to go along with this, I'll show you another view. You can kind of see how this would come together. So we're using an approach of using chainmail to cover the base of the palm and what would then wrap around the forearm to connect up to the cuff, or what is often called the gauntlet. And so that gives us a little bit more flexibility, partly because that chainmail can then conform to the different shapes of anatomy. But so it gives you that conformity, but it does not have the difficulty of printing that's associated with flexible materials. So we get kind of the best of both worlds. We get that sort of flexibility in that the chainmail can expand and contract, but it's something that can be printed on just about any printer out there. So that's another kind of exciting new innovation that we're incorporating here. This model has a whole lot of parameters. If we were to just kind of pull up our parameters panel here, you'll see there's all kinds of parametric values in here. Most of these are parameters that the end user is not going to have to worry about. These are things that are happening behind the scene. But some of these are parameters that the user will be able to control. So you'll take measurements from your end user, and you'll be able to put in different parameters, including things like, what tolerance values you need for your printer, and the scaling, and what size cabling you're using, and all kinds of different things. But what we realized as we got into this project is when we go to roll this out, when somebody needs to actually get their scaled files, in order to print a hand, what's involved in actually putting in all those parameters, scaling things, getting the STL files exported? We realized it was going to be way too complicated for the average user. And along comes Andrew with a great solution, which was to build a front end, essentially a web application, which can later move into a smartphone type of application, that can be used as a front end to guide us through the process of getting the measurements we need from the end user, putting in those measurements as simple values, and then let the software handle all the complexity of translating those measurements into these different parameters, generating all the files we need by talking to the server on the back end, and feeding those files back to us. Basically an enhanced version of the Thingiverse customizer, if you've ever used that. Thingiverse customizer is great because it allows you to kind of scale things and customize parts with just inputting values, but it doesn't really do what we're talking about here, this fully parametric scaling, where we really have full control over these different values. might be the kind of thing you could pull off, but not easily. So what we realized through this process is that using the approach that Andrew came to us with, we're not only able to provide a solution for this hand, but we're going to be able to provide an application that can be used for future designs, hands, arms, and other types of assistive tech as well. So we're really looking forward to building this application as a tool for really providing a more powerful way of getting customized files for printing all kinds of different assistive tech devices, starting with hopefully this new and improved hand design. So that's just kind of the context of what we're doing here. It's very exciting. There's a lot of things coming together here. A lot of great talented people have come together. I also want to give a shout out to our friends at Deloitte in the UK, who were kind enough to donate their time to help us with the UX, the customer interface, the user interface kind of aspect of this application. They did a lot of work, came back to us with some great results that I think Andrew is going to share here. So I just want to thank them for their great contributions. And Andrew has a number of developers working with him that are contributing to this. And it's just been so exciting to see all of the people that have put in so much work to make this happen. So with that, I'm going to turn things over to Andrew. Today, the focus is really mainly on the software side of what we're doing here in this application. I just wanted to kind of share a little bit about what led to that and how we approach this. So over to you, Andrew.
Well, thank you for the awesome intro. So my original design for the software, my initial idea was that when a user would want to get a device, they would start by inputting a series of measurements for their, like taking measurements around the radius of their wrist, potentially like from their wrist to their elbow, to kind of get a sense of the scale of the person's arm, and then we'd be able to pass that information over to an API running on a server that would be able to interface with some CAD software to be able to actually provide those parameters. So just to prove that this was going to work out and that this was actually doable, we put together a prototype, which I'll show a little snippet of a video of here. This is all mock data, doesn't work, but illustrates the principle. When somebody would want to create a device, they would go through, have this nice interactive flow for inputting measurements, where there'd be images showing exactly what steps the user needs to go through to find to perform each of these measurements. And then once they've got all of those measurements input, they'd be able to then go through a list of devices, select an appropriate device, and generate a set of STLs or 3D printable files from that design using those measurements. So as Jeremy showed, our design is in Fusion 360, and it has a very long list of parameters and different values that we can change to influence the final model that comes out. And so this software kind of acts as an interface between users who are able to perform those simple measurement steps and that much more complicated list of parameters. So by guiding the user through this interactive measurement process, we'd be able to derive all of the appropriate values to plug into that long list of variables for the model, and then run through some steps interfacing with the CAD software, and ultimately get a zip file of STLs that our users will be able to then directly drop into a slicing software and get set up for 3D printing. So what you just saw was our original proof of concept mockup. A lot of it didn't work. The export actually does function. That's been fully implemented, at least our original vision for it. But a lot of the stuff related to inputting measurements, managing different people who will be receiving these devices, we didn't have a very clear vision yet on what we wanted that to look like. So we were able to reach out to our friends at Deloitte, and they were super kind and made a huge contribution to this by producing this really large document containing all kinds of inspiration, various ideas and insights to help us better structure our application. This was pretty much all I got, was that video that I just showed you, an email describing what we wanted, and some screenshots. And from that, they built this information architecture, They sketched out all of the different flows that they thought the app would need to have. And then the super, super awesome thing that we're so thankful to have are these wireframes here, where they've gone through and they've created mock-ups for each and every piece of the application, following their own vision for it. And these are great. We're in the process of implementing all of these right now. So we don't have a working app that has all of these ideas integrated yet. That's the current stage of development we're in, is bringing this to reality. But we're just super happy with what they've got. They made the observation in our discussions that this should really be a people-centric app, and we should start by focusing on people. They're ultimately the most important part of this, the people that will be receiving these devices. So they suggested that we switch this over to start with a list of people, and to allow for a single person to have multiple different sets of measurements associated with them, because it's entirely possible that somebody might have 2 limbs with a limb difference, and we'd like to be able to keep all that information together, make it easy for our makers to keep track of which measurements belong with which people, that kind of thing. So these are some of their visions for what the people interface would look like. We get a little bit of information about the people. We have a list of different limbs that we have measurements for. We have a list of various devices that this person has had printed for them. Any kind of notes that we need to take down about that person. When we're looking at one of these limbs that they've added here, we'd have a list of various measurements that would be used to compute the parameters to configure the CAD models for export. And then we have some other stuff about editing various pieces of data for the person. And this wasn't something we had thought about in our mockups, but the Deloitte folks did. Having an interface to be able to go through and see all of the previous exported devices for a given person, or for all people. So this is an interface to be able to do that, go back and kind of see the history of the various devices you've exported. This is their idea for the interface to enter in a new person. Pretty standard stuff. And then this was their idea for printing a device. You would start by selecting the person who you want to print the device for, and then select which one of the limbs that device would be for. The user would then be presented with a list of devices that apply to that specific limb, and they'd be given various criteria. These are currently available in the device catalog on the hub right now, and they'd be available in the app as well, showing various criteria like how popular a design is, how hard it is to assemble, other stuff like grip strength as well be included in that. Once a user has selected a device to print, if there's any kind of measurements that they don't already have input for, we could guide them through the measurements process to get all of the necessary measurements inputted there. And then we'd be able to show them a export progress screen as we go through and in the background export all these things. And then they'd be able to download their results. This is the last piece here. This was their idea for how the interface to add a new limb would look. You can start by taking a picture, which is pretty useful because there can be quite a bit of diversity in people's limb differences in anatomy. Selecting the type of limb difference is very useful and important for future plans. Like if we want to add more devices that would accommodate more limb differences, we'd be able to better select a list of devices to show for a given limb by having this information. Be able to provide notes and such for a given limb. And then this would be the flow for inputting measurements for a limb, where these placeholders would be replaced with images that show how to take a specific measurement, and they would have instructions associated with those. So when we take this whole application flow and build it into a cohesive picture, we'll have a really easy to use tool for people to be able to take the necessary measurements of somebody who needs one of these devices, search through a list of appropriate devices for the limb difference of the person, and then very simply receive 3D printable files from a very complex CAD model. So this will really increase the accessibility of these more advanced devices that we're working on by not requiring this heavyweight CAD software and a powerful computer for it, making it simple to understand how exactly these devices are scaled. This should really open up a lot of opportunities for our various assistive devices to become much more powerful and flexible, have better fit and function. And like Jeremy mentioned, we would also like to eventually expand the scope of this application. And instead of just being a hub for hands or for various prosthetic devices, we could include all kinds of other assistive technologies. There's lots of really cool 3D printable assistive devices, like things to make it easier to open cans if you don't have very good control of your fingers, various stuff like that. We would love to be able to create a home for all kinds of content like that, especially things that are parametric or need to be configured or supplied with variables. Just makes everything much more customizable, much more usable. So that is our vision for the future of this application. And so far, so good. It's coming along nicely. There's one other piece of this application that is going to require a lot of development that we're still figuring out right now, and that is the actual interface with CAD software. So for our proof of concept, we actually just directly connect into Fusion 360, just the CAD software that our upcoming hand device has been modeled in. However, when we're going to deploy this application, there's quite a few problems with just using Fusion 360 in that way. And so we are going to be hopefully upgrading over to a Autodesk API specifically designed for this purpose, called the Design Automation API. I'd love to go into further detail about that, but we'd be getting pretty technical pretty quick. And if I'm being honest, there's a lot of things I don't know about this here yet. So we're in the process of establishing communication with Autodesk to hopefully get licenses of Inventor for our developers to be able to prototype and develop software that will be deployed to Autodesk's API to allow us to really scale this up and make a much more reliable and powerful product in the end. So that's where we came from, where we're at, and where we're going in a nutshell.
That's great. I'm curious if you could talk a little bit about how the project came together. I know Jeremy mentioned that there was some conversations and dialogue before you drafted the proposal, but maybe you could talk a little bit about that, the process of planning out this project, forging this collaboration with Deloitte. There's a lot of people that it sounds like you're also managing in terms of getting contributions from other developers. Tell us a little bit about that, about setting this up and maintaining these collaborations.
Sure. So my first real work for e-NABLE was on porting over an existing device of ours. I don't know if we made it, called the Phoenix, specifically the third version, from Fusion 360 over to a different CAD software called Onshape. The cool thing about Onshape is that it runs in your browser. And so this would make that particular device much more accessible and open to others, because they wouldn't need to have this very heavyweight Fusion 360 software installed on their computer. They just need to have a computer that can run a browser, which would make that much easier for people, say in like the developing world, to be able to use that device. So that was one of my first tasks with e-NABLE. And while I was in there, I started making things parametric, where I saw a possibility to do so. And my work on that led to me being included in on some of the meetings with the collaborative design team. And in those meetings, I learned about this awesome next generation device that's in the works. And one of the pain points that they were discussing at one of these meetings I attended was the fact that people were going to need to run the software to be able to export these models. And they were also going to need to have sufficient understanding to be able to go through and edit the variables to parameterize the model and to get a configuration that was going to work for their specific recipient. So pretty early in the process, they're starting to see the device was working great, coming along very well, but some of the other things related to making the device accessible to makers and such, new technologies, new challenges. There were some significant hurdles that needed to be overcome. And we were talking about various different ways to be able to do that. One of them was we were still considering Onshape as a potential replacement for Fusion 360 because they have lots of cool other things, like you can open a slicer directly in an Onshape project and all that. So we were looking at maybe a user flow where they'd make a copy of our model and then open up a slicer plugin for Onshape, and it would show them the configuration variables and stuff. But there were other problems with that approach. And in one of these discussions, while we were trying to find other solutions where we could potentially use Fusion 360, I pitched the idea of creating an application that interfaced directly with Fusion 360 to input all that information for the user. And from there, we started talking about how we'd actually acquire the information to configure the model. And that was kind of brainstorming our measurements taking process and being able to provide users with some clear pictures and instructions on such on how to take those appropriate measurements. From there, in a couple days, I threw together some prototypes. The first prototype was interfacing with Fusion and Onshape, both of their APIs, to be able to do that programmatic export, being able to provide the configurations to the models and then get STLs out. And then the second prototype was the little web application that I showed a video of at the start. That's how I started on the software front, but I pretty quickly realized that there were some pieces of this I didn't really know how I wanted them to look and feel. I have quite a bit of experience now with the designing and developing APIs and implementing web applications and such, but designing web applications still a bit of a blind spot. And the other primary developer on this, who I've been working with, who's named Lucas, was in a similar boat where he's also very good at implementing something that somebody else has given him, but we were having some trouble figuring out what exactly we wanted this app to look like. We weren't quite happy with the design we had come up with. And so while mentioning these kinds of things, Jeremy pitched the idea that we could reach out to our friends at Deloitte and see if they would potentially be willing to collaborate with us and help us out. They do have they have user experience or UX professionals, some wonderful folks. And so we were able to set up a meeting with them, explain what we were trying to do. And not long after, they came back with this awesome document with all of these great ideas and lots of good stuff for us to go and implement. So that was how we got in contact with Deloitte and got these awesome wireframes mock-ups back from them. I think that's been a majority of our external collaborations. Otherwise, it's been me and Lucas working on this software. And just recently, the guy who's doing a lot of the CAD work for this new device, Alexander, is he's interested in learning some software skills. So he's going to be helping us on that project as well. So we'll be up to 3. And while we were talking about making this application, the idea of creating a proposal for it, because this is a really large project, came up. And so we went ahead and figured out some formal requirements for our software and made a proposal. Unfortunately, as our needs and ideas for this have evolved, the process of a proposal becomes a little bit difficult. A lot of what we originally envisioned for this project has now changed significantly. The scope is still kind of moving under our feet. Software is unfortunately very difficult to follow a single plan for from start to finish. There's often lots of different hurdles and unexpected things, or just better ideas that you discover along the way that you need to be able to change and accommodate for. So we're still in the process of crafting a proposal because our end goal keeps shifting, but we're starting to really narrow down on what we want this to look like. And now that we've got these mock-ups, we've got a much bigger or much better idea of how much work is left to do on our web application. So our last big piece that we've got to figure out is how we're going to be interfacing with that design automation API I mentioned. And once we've got all of those pieces figured out, we should be good to get things finalized. We'll have a better understanding of what the end product is actually going to look like.
Great.
Can actually share a little good news with you there, Andrew. We
Oh,
have
yeah?
been approved for a license for Inventor.
Awesome.
With one catch, that we have to do this through this TechSoup organization that does the
Okay.
licensing for nonprofits. And there is a $250 admin fee. Now that is nothing for the platform that we need. It's clearly worthwhile, but it is something that we're going to have to take a vote on and get approved in the next week's town hall. So I got some discussion with John to see if we can figure out a way to get that going ahead of things by making some assumptions. But one way or another, we're within a week of getting that going for you.
Okay, awesome. Glad to hear it.
Hey, Alexander.
I totally did not forget about this.
That's okay. You missed the part though where I was, pointing out all the great work that you did at the beginning. So now that you're here, we get a chance to thank you in person for all the design work that you've done that led up to all of this. Really impressive work. We talked about all the parametric stuff, and I showed people a little preview in Fusion.
Oh, nice.
I wonder, Andrew, would you mind sharing your screen with the proposal and maybe talking a little bit about that process, what you pitched originally, and some of these things in the scope that have shifted? Because I think for some volunteers who have big ideas, it can be a little bit intimidating to look at our e-NABLE process. I think your proposal was just a really great example of
Maybe zoom in to fit the page if you don't mind there. My eyes aren't that good anymore. There you go.
Maybe walk us through it a little bit. You don't have to read it word for word, but walk us through the proposal and how you guys came up with this structure for it, and some of the things that, now that you're recognizing the shifting scope, what you might change and what recommendations you have for other people with big ideas that are looking for funding. Sure.
So I'll start out by saying, when you go to make one of these proposals, you're kind of you're given a rough structure for them that is provided to you as a template when you make one of these proposals. So you're not starting from scratch. You have some idea of what's to be expected to be contained in this document. When we went and made this proposal, one of the first things we had to think through was there's a lot of background knowledge and explanation required just to make sense of why this is even useful or what it's going to do. So that was information that we wanted to convey immediately. So this only slightly deviates from the template they provide, but we start out with kind of, I call it the elevator pitch, as succinct a description of why we need this and what it's going to do as possible, with just a couple sentences in bold to really drive home the core of what we're doing.
In fact, I think I need to probably go back and add this into our template, because I love what he did here. This was the one bit of feedback I gave him, because Andrew did all the work on this. But I said, I was the one that pointed out, we really need to kind of make things clear right up front, because people aren't going to read a long thing. They're only going to read the first bit. And if you don't grab them there, then they're not going to read the rest. And so he did a great job on putting that together, but I need to work that into the template to encourage others to do the same. So I love having that elevator pitch up top.
And if people are going to take on similarly large proposals, I would highly recommend it. If you have graphics to illustrate what you mean, I think that's also really useful. Like, here's an example of the difference between linear and parametric scaling, where you can see the key geometries are being distorted in a linearly scaled piece, but preserved over here. If your proposal would include something similar like that, difficult to explain using graphics, really helps make it clearer what you're trying to convey. So we started out by having an elevator pitch where we kind of described what exactly this does, explain the problems with linear scaling, the solutions offered by parametric scaling with the new challenges, and then talk about how our application seeks to solve those new challenges introduced by parametric devices. Then we go into a description of the proposed project, starting from kind of the premise. And this is where we can really elaborate and expand on what we said in the elevator pitch. We can provide the details and the necessary background information for anybody who really wants to understand what's going on here, what we're doing, why we need this. We talked about how we set out at the very beginning to prove that this process was possible, and then discussed a little bit of our process and progress as we've developed this application further, other needs that we've identified, various stuff like that. There's also a section from the template that we thought about cutting, but we left it in because we feel like this would be another good place to, now that we've really elaborated on everything, to have one more succinct reminder, kind of compress that all back down to still the key points. This is not from the template. This is pretty common to any large software. When you're trying to design a larger piece of software, one of the very common practices that you'll do, like they'll teach you this in school if you go to be a software engineer, is to come up with a bunch of system requirements. And so we did that. We sought out the most important pieces of what this application would do, and we wrote them up in the language of application requirements to make it clear what exactly the software would be capable of. Then we had to figure out how much work this application was going to be. Our estimates are completely off because our scope has really changed a lot. We've already blown through all of our estimated time.
But it's important to point out that this is written up as a discussion right now. So we actually have not yet put forth a voting proposal.
Right.
It would have been probably more problematic if people had already voted and approved on something and then the scope was changing. That's not what we're saying. This is just in a discussion phase right now. And we have not, that's why, in fact, he hasn't set up the voting yet, because we have to clarify these details.
Yeah, our scope has changed hugely since we made these initial these estimates, and I held off on bringing this proposal to a vote and actually formalizing this and kind of nailing down this document kind of for this reason, because we some of our requirements aren't quite the same anymore, and the estimates of work are going to need to change a fair amount because we're doing a lot more than we had initially planned on. That's just kind of how software goes. So this is going to be different for anybody who's doing non-software stuff. Software is notoriously difficult to get time estimates of. It's pretty much a specialty. If you've got like large software organizations, you've got like project managers who stay on top of this kind of stuff, come up with these estimates based on past work, working with the engineers to do that, keep an eye on the progress of the project so that they can get a more accurate moving estimate. Estimating the amount of work involved in a software project is notoriously difficult. So we did what we could. And I would imagine that this process and the results will look very different for somebody doing a non-software project. But I would recommend, if you want to do a really large project like this, try and break it down in the same way that has become very standard for estimating software, which is to try and break it down into the smallest chunks that make sense and can be compared to other pieces of work you've done in the past. That's a really good way to try and get a better estimate on like a really large piece of work, is to break it down, itemize things, and try and find previous such things you've done that are comparable in difficulty and length, so that you can get some good ideas of how much time and effort is going to be involved in those things. We came up with a timeline for completing this project. I think we will be able to get our front-end mock-up done on this timeline. We're looking good there. The back end, if the scope was the same, we would be ahead of schedule there. The scope has changed significantly, so we're going to need to redo that particular part of the estimate. if things go well, we're still on target for our minimum viable product deployment date. We've got a lot of work on the back end, a lot of unknowns that we need to answer, specifically pertaining to this design automation API and how much work this is going to be to use. So this might change, but we're still looking pretty good on our timeline. Excuse me. Our process for getting a timeline was to look at the amount of hours we had estimated for each piece remaining, and then just divide that by number of people and hours that those people were going to be able to put into the project per week to get a rough timeline. And be generous with your timelines. That's a piece of advice I would give to anybody trying to estimate large projects like this, because you'll almost always run into things you didn't expect, or you'll find new opportunities to provide increased value that you want to include in what you're doing. So be generous with your timelines. Some of this stuff is specific to software again, like our development tools we made a list of just to think if any of them would need to be, would need a paid subscription. We believe we'll be able to get on the free plans for all of the tools we thought of though. I guess this will now change given that we need licenses of Inventor and some of that kind of stuff. We also wanted to be clear about who's responsible for which deliverables. I believe this was part of the template, was making a list of the deliverables and whose name is attached to each one of those obligations. And then at the end of the template, you need to come up with a final figure that you're asking for. So we showed our math here and how we came up with our numbers.
And I wanted to jump in on this point because I think Andrew did something really wise here, and it's something that I wanted to talk about as far as, you know, a good model going forward. One of the challenges with e-NABLE, as you know, people may or may not know, is that nobody's in charge. There is no actual e-NABLE, you know, corporate headquarters. There's no e-NABLE board or anything like that. It's literally a community of equals who, best as we can, we make decisions together. And so that's why we try to do things by voting on Lumio and discussion on the hub, et cetera. And I'm mentioning this because here's a good example. We don't really have a standard for when do we or do we not pay somebody for different kinds of work, and when we do, how do we go about that? Point in case, when you need a really significant development project, that's the kind of thing that might not be able to be done on an entirely volunteer basis. It's a big time commitment from people that may not have that time available. And so I love the approach of that Andrew took here of taking your going rate, you know, on the market. This is what I work for. This is what I, you know, sort of bill for my time normally, and then cutting that in half, basically giving e-NABLE this 50% favored discount. I'm not saying that necessarily needs to be, you know, set in stone or anything, but I like the idea of that kind of being a standard approach to these things, to these types of projects, of kind of taking what your going rate would be and cutting that in half. Just so that you are providing some benefit to the nonprofit community, but at the same time able to cover costs and that sort of thing. So I thought that was well done and worthy of more discussion going forward as far as, you know, adopting that more as a common practice.
Yeah, we're happy with what we came up with here. I think this makes it reasonable for people to kind of take on larger projects. All parties benefit kind of deal.
Yeah.
This is not a piece of the template. This was something we added on, which was to discuss basically just take down a list of all of the cool ideas that we've come up with for stuff that we would like to do later on that aren't included in this proposal. If somebody is doing a software project, I would specifically recommend doing this, both because it gives you a good idea of it gives you a good place to record some of these ideas that you have for the future. And it also makes clear what you are not promising yet. I think that's from the perspective of kind of protecting yourself and making it clear to people what specifically the proposal entails. This is a good way to do it. Specifically saying stuff.
I agree, Andrew, that it protects you, but I also want to point out, I think the benefit of this also is that it adds to the understanding of the value of what is being proposed. If you understand what can later be built on top of this, and this is what we have envisioned for the future, I think that's also helpful to let people fully perceive the value of the work that is being done in this phase that's being proposed. So I think it's good for both reasons.
Absolutely. Yeah. People being able to have an understanding of what this, what a proposal could evolve into, gives them a much better perspective on how much value it will provide to the community. So being able to discuss some of the future plans you have for stuff is always very useful. I can touch on these really quick. We don't currently have this. This might slip into the MVP depending on what we need. But adding lots of support for technical configuration of generated models. Like right now, you can configure models specifically to people's limb differences and like taking measurements and kind of stuff like that. But we don't have a whole lot of room for customization right now with like changing the diameter of the channels for cables to go through for our assistive hand, or changing the types of fasteners you're using and stuff like that. So this is something we haven't built in yet. This might be included in our scope. We'll make that decision before this proposal goes to a vote. One of the harder parts of sizing these devices correctly is that it can be difficult to tell if the pocket, just kind of the it's the part where your palm would be. It's like the hollowed out part of a palm of one of these hands. Determining if your limb is going to fit into that pocket can be non-trivial. In the past, we've done this by taking pictures with a ruler included, bringing those into CAD software and doing like a virtual fitting. That works well, but it's labor intensive. So we are hoping to be able to create some features to help kind of perform that virtual fitting on your own and make sure that the device you are going to receive will fit you before you go ahead and commit to printing it. Something else we want to do that's going to be really difficult, not necessarily from a technical perspective, but probably from a legal perspective, and navigating those difficult waters will be adding a database to be able to store user data and allow them to access their data across multiple devices. As it stands right now, any and all health-related data, like taking measurements of people's limbs, just exists on the user's browser. That way, we are totally hands-off. We are not holding on to sensitive health information that might have HIPAA requirements or other such legal requirements based on the country that the user is from. So in order to just sidestep all of those legal regulatory concerns and where data is being stored, et cetera, we're just storing that information in the device's browser cache. But long-term, we would like to make that information accessible to the user on multiple devices. And we would like to allow the user to share their information with somebody else. So say you were the parent of a child who wanted to receive one of these devices. You as the parent could download the app, go through the process, get all the measurements ready, and then share them with a maker who is actually going to do the printing for you and all that kind of stuff. So enabling people to do that kind of sharing with the database and all that would be really cool. We're hoping to be able to do that. Authentication will actually be implemented somewhat in this in our MVP. We're going to be able to support single sign-on through the e-NABLE hub. So you will be able to log into the e-NABLE hub, create an account there, all that, and then have that account be accessible and usable from the app. So we'll be able to know who people are. That information won't really do a lot right now, like who you are. But as we move towards the future, that information will become more and more useful. Last thing, not as interesting to non-technical people, we'd like to be able to support having things modeled in multiple different CAD softwares and bundled up in the same export. Can't be done at the moment. Probably not useful enough for the MVP to justify it, but something we'd like to do. So that is that's our proposal. That was our process for creating it.
And did you get any feedback from the community? If you go down, were there any comments or?
Just a little bit. John liked it. And Bob thinks this will be really valuable.
Awesome. So that there is a benefit in sharing these
for the record,
plans even before they're
I was going to say, for the record, we did put this up for discussion, but we did not use the option of notifying the members of Lumio like we sometimes do. I hadn't pointed that out to Andrew. So
Yeah,
this
we
just,
haven't advertised this at all
yeah,
yet.
it just
We
kind of
haven't
showed
really
up.
gone out for requests.
We knew it was going to change, and so we decided to hold off on promoting it. Once he's finished with his kind of clarifying scope and we update this, we'll then notify people probably a little bit before we flip it over to a vote.
Yeah, I think we'll get a lot more feedback from the community. We'll hopefully be able to have some community members using the software before we consider like the MVP done, and get some testers in there and get feedback from them as well. So when we've got this proposal really finalized and nailed down, when some of these big unknowns have been answered, we'll be able to go out and get feedback from the community and hopefully include that feedback in our designs.
That's great. Well, any last recommendations or ideas or challenges you'd like to share with the community? We've got a couple minutes left. It looks like it's just the four of us, so maybe we can, in the post, I can add your email and we can get Q&A sort of asynchronously offline, or hopefully in the hub if people want to share publicly. But
Yeah,
last
sure
thoughts?
thing.
Yeah, I just want to take a moment before we wrap up here to thank Andrew for really the phenomenal work he's done. He's put a lot of time and effort into something that may or may not turn into a funded project, but regardless, he's done a tremendous amount of work along with Lucas, who I also want to thank. I haven't been working directly with, but I know he's doing a lot behind the scenes. So thanks to both of you guys for all you've done.
Very welcome. Yeah, closing remarks, I guess, don't be afraid to take on some of these big projects. You never know where they're going to go, and you can have a lot of fun along the way, really help people out. Something like making this application from the ground up is pretty intimidating at the start, but so is any big endeavor. Don't be afraid to go for it. If people want to get in contact with me, my email will be included. You can reach out over the hub. We also have an e-NABLE Discord. Feel free to join there, and you can find me. My name on Discord is F of X, so you can find me in the Discord server. I'm very responsive on Discord. If we have anybody who is like into software and would be interested in working on this project with us, feel free to reach out. I'd be happy to have hands. Everything is in TypeScript, with the exception of some code that we haven't written yet, which will probably be in C#. So if anybody has those skill sets or has interest, feel free to reach out. I think that's all.
Great. Awesome work. And again, it's a pretty impressive collaboration going on. Deloitte's in the UK. There's been some contributions from and sort of preamble work from Alexander in Romania.
And our design team includes, Marco is he in, where is it, Germany? I know he's overseas. I can't recall exactly where he is, but we have several others on the team that are just coming from all different places. It's really just been a fun collaboration coming from a lot of different people in different places.
Awesome. So great work. Thanks for sharing. We will add this to the archive in the focus follow-up workshops, and stay tuned for next month. We'll have another workshop from one of our volunteers the fourth Friday. And until then, keep on with the good work. Thanks so much.